First, select the product from the product list. Select manufacturing type. If you want to order manufactured product, which you've designed, select 3D printing or CNC milling option. If you want only to download your design 3D model, select download option. Your order will automatically receive an order ID. Add patient ID for easier order identification. Select patient gender, add age and measured length of the patient's foot, which will be used in the search engine to find the most similar shoe last. Upload patient 3D scans via form. Ink images can also be uploaded in this form. Select pathologies for the specific client case. Selected pathologies will be used in the search engine to find the most similar shoe last. Also, recommendations for the design will be displayed for the selected pathologies. Select the shoe last parameters for your order, which will also be used in the search engine to find the most similar shoe last model from the database. Define the shoe last's toe spring and heel heights. These two measurements are marked with asterisk and are required. Other circumference parameters are not required. However, by adding them, you will have more accurate results in the search engine. To go full screen, you can click the F11 key on the keyboard to maximize the size of your screen. To see a preview of your 3D model when in File Explorer, click on the Show the Preview pane button to enable a preview for your 3D model. You can change the size of the menu and the toolbars by clicking the Ctrl+ or Ctrl- keys. To save any changes, click on the Save button. You can use the Undo or Redo buttons to undo previous actions or redo them. You can scroll the mouse cursor on top of the button and it will display the name of the button. When you click on a function, you will see a text bar, which explains how to use the tool. Smart3Dworks has inbuilt shortcut keys, which simplifies object selection and manipulation. To select multiple objects, use Control key. When multiple objects are selected, you can unselect a single object by holding Alt key and clicking on the object. When holding Shift key, you can create a selection box. You can use numpad keys on your keyboard to change the current view with 8 top, 6 right, 5 front, 4 left, 2 bottom, 0 back. By clicking the num7 key, you will be able to rotate the camera around your model in the current view. By clicking numkey 7 twice, your view will go directly into perspective view from the top corner. When sculpting tools are active, you can change the size of the radius of sculpting tool by pressing plus or minus keys. You can exit an active function by clicking the escape button. When you activate the shape correction tool, and you select the control points, you can use the arrow keys by holding them or by clicking them to move the control points position from your current view. You can use F8 key to activate the orthographic mode, when drawing polylines, placing measurements, or changing the position of the objects by using rotate or move buttons. You can also change the camera view by clicking on the different sides of the cube. By clicking the home icon, you will go into the perspective view. If you have moved your objects of your view field, you can select your object from the object functions tree and click on the eye icon button to automatically change the view to look at the selected object. You can disable or enable the grid. You can enable wireframe mode to be able to see the triangles of the mesh. It's recommended to turn it off when it's not used because it takes additional calculation resources to display the mesh and it might slow down the performance when active. The system provides a 3D modeling guide, wizard, which provides you with the functionality and the tools which are needed to be used in separate steps. Wizard has a list of steps provided with the information on what needs to be done. To enter the wizard guide, click on any of the steps that you want to open. After clicking it, the color of the step number will change to red. Once the wizard is active, it will hide all of the unnecessary tools from the horizontal and vertical toolbars and will leave only the necessary tool. To exit the wizard at any time, just click on the currently selected step again, and you will exit the wizard. All tools will be visible again. In the recommendation text box, you will see the modeling process workflow, which is listed in numeric order, and what needs to be done. Wizard texts are pinned and are always displayed in the top left corner. These text boxes can be unpinned by clicking on the pin button to show text boxes only when moving the mouse cursor over the wizard step. There are two types of buttons displayed when the wizard is active: required buttons to use for 3D modeling, which are highlighted in green with numeric values, and optional buttons, which are not always required to be used. They are not highlighted and have labels with letters. Green highlighted button numbers correspond to the order that they have to be used. They can also be located in different areas of the screen. After following the main workflow, there are also optional steps, which are needed if your imported data is not fully preprocessed and prepared for the work. Text after the note provides some tips, which can be useful while following wizard modeling steps. After completing the instructions provided in the step, you can click on the next button to go into the following step, or you can click on the next step directly to open it. After completing all of the modeling steps, you can complete your order and download it or manufacture it. You can select an object by clicking on it in the Object Functions tree. You can change the name of the object by double-clicking its name. You can change the color of the object by clicking on the color icon. You can change the opacity of an object by clicking the opacity value. The minimum opacity is 30%. You can hide an object by clicking the eye icon in the visibility column. If an object is hidden, you can unhide it by clicking on the eye icon again. To keep an object visible without being able to interact with it, you can click on the lock icon. In that case, you won't be able to use the tools on the model. You can delete an object by clicking on X icon in delete column. You can increase the size of an object functions tree by dragging the bottom edge of the window. You can hide the object functions tree by clicking on the title bar Object Functions, and unhide it by clicking on Object Functions again. To start modeling, you will need to upload your patient data into 3D Scene. First, you would need to import 2D ink print image if you haven't done it already. Then it is recommended to change the color of a model for easier model identification. Go to the back view and click on the rotate function. First, click on a point from which you will generate a rotation axis, then place a point from which you want to rotate an object. Then move a third point to see the rotation of an object. To confirm the rotation, just click to place the third point. Then perform the same rotation from different camera views to align the model correctly. Use the Move tool to position the model above the ground plane. If you have both scans in a single object, you can split it by outlining a foot with the polyline tool. Make sure that the polyline is closed, its first point meets its last point, to be able to split 3D models. You can close the polyline by placing a point near an open endpoint of the polyline. After drawing a closed polyline contour, then use the Mesh Split tool and select the 3D foot model, closed polyline, and click on the Split Mesh button to split the 3D foot model. After you split the model, you can see that in the object function tree there are two models now. You can change the name of a 3D model. If your model has some additional artifacts, it would be recommended to clean up by removing excess area. Draw a closed polyline contour around your model. You can draw a polyline in smaller intervals or use multiple polylines and then split the 3D model and delete the separate artifacts model. Click on the Mesh Split button to split the model around the polyline area. You can delete the unnecessary objects by clicking the Delete key on your keyboard or clicking the X button in the Object Functions. You can also enable the wireframe mode to see the mesh density of your scan. Click on the Reduce Mesh button in order to simplify the mesh. By reducing the vertex number on the 3D model scan, it will simplify further calculations and increase the performance of other tools. By clicking on the object, you will see the vertex number at the left top 3D scene corner. It is recommended to use a model with a vertex count of around 10 to 20,000, depending on your computer specifications. You can specify the number of vertices that you wish to reduce, or you can specify a percentage to which you want to reduce the selected model. To perform the model vertex reduction, click on the Reduce Mesh button. First, you need to change the visibility of your 2D image. You can position it next to your foot model, then it's easier to see if the image scale is correct or if scaling is needed. You can activate the measuring tool and place 2 points on the 2D image to measure the length of an image. Usually, an ink image also has a ruler, so you can measure a distance on it to see if the measurements are matching. Then you can open the scaling tool and define a 100 mm line on the image by placing 2 points on the image to scale the image to its real scale. You can measure the image again to see if the size of the image is correct. If a single image has both foot scans, you can split it, using the split plane tool. Click on the mathematical model search button and depending on your foot side, select if it's a left side, left foot icon, with the letter L, or if it's a right side, right foot icon, with the letter R. Then you can perform an auto alignment. First, make sure that your foot model is parallelly positioned to the ground plane. If not, you can use the rotate tool to rotate the foot. Once it's parallel, click on the I approve box field, and you will be allowed to place 3 points to automatically position the foot model. You can place points on the foot model by clicking the left mouse button on the foot model surface. If you accidentally place a point incorrectly, you can remove a specific point by clicking on the placed point. Once all 3 points are placed, you can perform automatic point detection to increase the accuracy of the foot model search. Then click on the closest model search to find the most similar shoe lasts from the database. The system will display the top 5 most similar shoe last model cases from the validated shoe last database. Below each model, you can see the difference between the parameters of the shoe last, which you've added. If you haven't specified some parameters, it will give you the information, no input. If you wish to see the difference between your added circumference parameters and the circumference lengths of the shoe lasts from the database, you need to click on the Order Parameters hyperlink and fill the empty circumference values into the form. You can import multiple cases to compare them side by side. It is recommended to change the colors of the shoe lasts that you import from the database. Then use different camera views to select the best fitting shoe last. Remove all unused shoe lasts, and leave one, which you will work with. Measure and modify heel and spring heights. You can place 2 measurements in a 3D scene and then modify the foot model heel and toe spring heights according to the measurements. Place a point on the ground plane and add the measurement distance by writing it with the numpad keys. Do the same for the toe spring height measurement. Click on Shape Correction tool and select the first, Generate Lattice 1 button to create control points. Select multiple control points by holding the Shift key and modify the heel height. Use the Move tool to change the position of the selected points. Then modify the toe spring height using the Rotate tool. Then you can remove the measurements by deleting them from the Object Functions tree. Option 2, How to measure the heel and spring heights. You need to click on the Measure Cross-Section button and click the Add Z-Axis Measurement button, then place a point at the bottom of the heel and click the Confirm button. Do the same for toe spring height measurement. Click on Shape Correction and select one Generate Lattice to create control points. Select multiple control points, holding Shift, and modify the heel height using Move points. Then modify the toe spring height using the Rotate tool. Then you can remove the measurements by clicking Remove All. Then you can modify the shoe last model instep and spring heights according to the foot model heights. Use Correction tool to modify heel height and spring height. You can also view the knowledge base recommendations, which are displayed according to your selected pathologies, to guide you with the shape, arches, heel height, and spring height decisions. Use the Shape Correction tool to create control points to modify the shoe last shape to match the shape of the foot scan. Click on Control and the first control point box button to create first small size of cage control points, which has the smallest amount of points, to define the general shape of the shoe last. Lock the footskin model, so you will not be able to modify it, but you will see it as a reference model. Hold the Shift button to create a selection zone in order to select multiple points at once. When control points are selected, you can use on Rotate tool to rotate control points, which are selected to modify the 3D model area which is nearby the selected control points. You can remove the control points by clicking the Remove Lattice button and then creating new control points on the selected object. When control points are selected, you can use on Move tool to move the selected control points, to modify the 3D model area which is nearby the selected control points. Delete the points with the Remove Lattice button and use a different camera view to modify the position of the points. When you have selected multiple points, you can use the Shift plus Alt keys to quickly unselect certain points from the ones you have already selected. You would need to change the camera view to do so. These shortcut keys will help you to select certain points faster. You can modify different shoe last areas, including heel, ankle areas, arch, and toes. Third control point box button is used to adjust small details of the 3D shoe last model shape to match the foot model. Change the ink image visibility and position it according to the imported shoe last. Create circumference measurement by clicking on Add Girth and placing 3 points, according to the 2D image. By clicking Confirm button you can place your circumference measurements. You can modify the circumference by selecting a specific circumference that you want to edit by clicking the Modify Girth button. Then select which point you want to modify and click on the 3D model to change the position of the measurement point to move it. You can also use the Shape Correction tool to modify circumferences manually. Use the Add Sculpting tool to increase the size in the specified area. You can change the intensity to increase the effect of the function and radius of the affected area. Use the Subtract Sculpting tool to reduce the size from the specified area. Use minus key to reduce the radius size of the sculpting tool with the keyboard. Use the plus key on the keyboard to increase radius size of the sculpting tool. Use the smooth sculpting tool to smooth selected areas. Use the pinch sculpting tool to pinch the edges of the shoe last. Use the grab sculpting tool to extend the ankles of the shoe last. Use the flatten sculpting tool to flatten the plantar face. You can specify the circumference size to increase its size, using the girth deform tool. Then you will be able to place 3 points on the shoe last. First point should be placed on the side of the shoe last, second will have the largest deformation of the shoe last, the color of this point is orange, third point should be placed on the opposite side of the shoe last. By placing 3 points you will see the current measurement. Then you need to add the new value of this measurement. Note, this measurement must be larger than the one you've measured. You can undo the change and then change some of the parameters and do the deformation again. You can also define the deformation distance to both directions of circumference line. Once you click deform, the circumference will increase in size. You can undo the change and change some of the parameters and then perform the deformation again. You can change the circumference position to a different area by reading 3 points in the different area, or you can exit the tool and open it again to remove previous points and add 3 new points to place the circumference. You can specify shin circumference by selecting deform shin. You can place 3 points on the shin in any order, because when the deform shin option is selected the circumference will be deformed evenly to all sides. You need to define the girth length of the new measurement and deformation size, just like for foot deformation, and click the deform button. After you have finished designing the shoe last, you can mirror the shoe last by selecting an individual plane from the horizontal bar and adding the distance between your designed shoe last model and mirrored shoe last. To complete the mirror tool after selecting a plane, to which you want to mirror an object, exit the tool by clicking on the mirror button again, or clicking the escape key. You can make adjustments on the mirrored shoe last model if they are necessary, or you can repeat the whole 3D modeling guide on the other foot as well if the models are completely different. You can compare mirrored shoe last model fitting with the other side foot scan. If there's a difference between the opposite sides of the feet, you can go back to modify shoe last to match foot model shape, step and perform additional modifications for the mirrored shoe last to match other foot scan as well. After you have both shoe last models designed, you can click on the order button, save the order and review if all parameters are correct. When you want your order to be manufactured, you can also leave a comment for the manufacturer to specify some details regarding your order. You can click the Add to Cart button after reviewing order parameters to download the files or manufacture the product after completing the payment. To complete the payment, go to the cart and check out the order you want to use. If the cart has more orders, you can remove them from the cart by clicking the X mark near the order. To go to checkout, click on the Checkout button. Select the payment method and proceed with it. After the payment will be completed, your order will move from the My Orders page to the Paid Orders page, from where you can download it by clicking on the Download button next to your order. If you have placed an order for the production of shoe last to be CNC milled or 3D printed, then you will see various manufacturing statuses in the Paid Orders window. You will see different statuses for when the order is approved, ordered, and shipped. If you want to prepare a 3D model for 3D printing, you can use 3D Printing Library to import separation elements to divide the model into separate closed parts. You need to select which type of separation elements do you want to import for high or low shoe last. Change the separation elements' colors and opacity to see where one part ends and the other begins. Then you need to create a copy of the shoe last. Select both of the separation elements and position them according to your shoe last model. To separate the shoe last model into two separate parts for 3D printing, click on the Boolean difference tool. First, select the shoe last model. Second, select one of the separation element models that you have imported while holding the Control key. Click on the Boolean difference button at the top. Repeat the separation process. Select the Boolean difference tool, and select the copied shoe last model and the remaining separation model.